right, so this is orchestrating the complexity of production infrastructure upgrade with Salt. Yeah, long name, but hopefully the presentation's a little easier to digest than the name. All right, so about me. So my name is Justin Bradfield. I work at Cazena. Cazena is a startup based in Waltham. I'll cover it a little bit more later. So I'm a senior engineer in charge of our upgrade. I graduated in 2013 with a BA in Comp Sci. And the reason I'm telling you guys this is that I really haven't been doing system admin stuff. I don't consider myself a sysadmin. I really consider myself a developer. In fact, I did web development the first 2 years at Cazena. I went to Startup Institute to learn web development so I could get a job at a startup. And when I started at Cazena, we were doing some database deployments and just had no idea how to do them, right? We were just very confused. We tried Chef. We tried Whir. I don't know if you guys are familiar with Whir. My guess is no. It's a big tent project that is just defunct entirely now. But I heard about Salt and tried it out, and within like a couple weeks, I had Hadoop clusters rolling around in the cloud. So it was really smooth. I found Salt to be one of the easiest things to use, and we've made a lot of bets on different technologies. We went with Go, Docker, and they're great technologies, but I think Salt so far has been our biggest win for early decisions in our software. All right, so just a little bit about what I'm going to talk about. So first, I'm going to go over what Cazena is. That's just really going to set the stage for everything else I'm talking about. We're going to talk about some of the upgrade challenges that everybody's going to have, and some of the driving forces to why we need to upgrade, and what's going to push our timelines for upgrade. Some of our first upgrades that we did at Cazena, I'll give a little example of those and say what kind of went wrong during those. And then I'll go over how Salt helped us with our upgrades and how we ended up getting those much faster. I'll go into the weeds of that a little bit, and then talk about some of the improvements that we're planning on making with using a little more cloud services, and definitely a lot more Salt. So this isn't really going to be based much on continuous integration or upgrades that are, you're generally going to see on like a web server. We have a slightly different product. We are database as a service, so our goal is to simplify data and analytics for our customers. And we do that by being a fully managed, cloud-based, big data as a service company. So that's like a lot of buzzwords. So to break it down, it's really, we just give our customers databases and tools so that they can perform the analysis and the business logic that they need without them having to worry about database security, database tuning, performance, DevOps. Really, we just try to bring this environment right onto their premise and make things a lot easier for them. So that's our real goal. There's also a big push. We're finding a lot of interest in partner companies that have a tool that works off of Redshift or works off of Cloudera, and they want to provide the service to their customer, but they can't deploy Cloudera themselves. So they have to find, either hire some system engineers or go with a managed service or have the customer deploy it. So they can also come to us and then give the customer a full product. So that's really, we're helping to simplify things. So we have some unique Salt usages. Most people probably have a lot of these, but maybe not all. So we have multiple Salt masters. We launch a different Salt master for every customer. Every customer is in a completely isolated environment. We have enterprise databases. Some people might have that. Multi-cloud provider support. We have a lot of resistance with people being on Amazon. Some people absolutely fine with it. Some people just directly refuse. So in order to get some of the customers that just aren't about Amazon, we also support Azure, which has been great. Azure's been very helpful. They've got great customer service. We have tight service windows. We do have service windows, so this isn't going to be targeted to like a rolling upgrade that you might see in a web server. And we're very, very security focused. All right, so some of the upgrade challenges, and everyone's going to have these service windows. So really upgrading the project or the product in a given service window is going to be an issue. Scheduling service windows and making sure that everything is ready for the service window, of course. Supporting the upgrades, so sometimes upgrades just fully automated, and you don't have to do anything. That's not us yet. Ideally it is, and support just says everything's upgraded, we're good. It happened automatically. The next stage that we're trying to get to is push buttons, so they say we want to upgrade, we give them a little button to hit, and then the system is upgraded within the service window. That's also good. The point we're at right now is a couple shell scripts that supports running, and we have, these guys are just awesome. They're very technical. They like being in the shell, so it's kind of good right now. We got lucky, I think, with the people on our team. And the last thing is compatibility, and this is like a devastating one where you have some security reason or some feature reason that you have to, or licensing reason possibly, that you have to upgrade a package in your product. Maybe it's on a production server, and it just doesn't fit, right? It breaks another service that you've created. It breaks a third-party service. So handling these compatibility issues are giant upgrade challenges, and really just require a lot of testing, right? So you just have to be very vigilant with the testing on those. So if you're going to have all these problems, you have to have a reason to upgrade. The reasons that you upgrade, these are entirely non-comprehensive lists. There are tens of reasons more than what I'm giving you for both of these. But you have stability enhancements, you have security, and you have new features. So you definitely want to make your customer happy with your stability, give them all of the new features that they would want. But the big one there, front and center, is security. Your customers generally aren't going to leave you right away if you're not stable or if you don't have that brand new feature. But as soon as you lapse on security, you start running into risks of data breaches. So maintaining security patches and compliance is a big one, and it is one of the largest driving factors that we have for upgrade, such that we actually have to speed up our release cadences in order to stay up to date on all of them. All right, so our first upgrade. And this is when we had one customer. If you don't have a customer, you probably aren't concerned about upgrading. What you're concerned about is backups and being able to restore your customer. You're concerned about keeping them happy and making sure that you don't lose their business. So that's kind of what we had. We had a customer that knew that they were our only customer, so we had a lot of sympathy. So they give us a good service window, and they were kind of willing to accept some of the bugs that might come up. We had a good deployment functional test framework as well as backup and restore framework. So we kind of hammered those to make sure that those were stable. But the ability, or the upside of having one customer is also support just has to run one command and then they're done, right? They can spend a lot of time on it without really losing support for your other customers. And the cons that we had is we had zero upgrade process. We really hadn't thought about it until we had a security patch. I think we had other ways of handling these things, but we hadn't really thought of our upgrade process really. All right, so the first thing that we should go over, this is our infrastructure overview. This is very high level. It's this isn't what our infrastructure looks like necessarily, but it is a very good, showing for what's important to this talk. So this is our infrastructure, and that's going to be in the cloud. So this would be in an AWS VPC or an Azure VPN. And we just have some subnets and firewalls around this. And we have a public subnet and a few private subnets. We're going to have a Cazena services subnet, which is going to store a lot of the database management. So things that we might need to help the customer move data in or keep track of identity management users or possibly even provide some additional tooling. And backups and SaltMaster, of course, is going to be on there so that we can apply our configuration. And our SaltMaster is actually a master of every node in our product. So it manages the gateway VPN, the Cazena gateway, which is an agent that we have on the customer premise to kind of bring our services into them. And then it's going to manage all of the Hadoop cluster configuration settings, deployment, upgrades, everything on there. Right, so here's a simplified view of that. So our first upgrade, this is literally what we did. We backed up our V1. We launched a new instance. We moved all of the data, and then we transferred the elastic IP. So how many guys are familiar with elastic IPs on AWS? All right. So what we did is we had an elastic IP that was attached to a DNS record, and the VPN tunnel was connected. It knew they had firewalls set up, the customer had firewalls set up for this EIP, basically. So we had to keep the same elastic IP. So what we did was basically got everything set up, transferred all of the data, made sure everything was good, transferred the EIP, and then the customer was dropped the connection, up the connection, and was back connected to our product, and this time it was on V2. So in order to do this, we had to spin up an entire new version of our product, which takes a while. It doesn't take that long. It's like an hour and a half, an hour. And then we had to transfer all of the data. So we're talking like terabytes of data here, and that's just no good. You don't want to be in the position where you're transferring data when it's in the terabyte size. It's just too slow, and it's costly on all of these cloud providers. So it worked. It worked fine. The customer was basically happy, but it was a very manual process. It took us like 14 hours for the data transfer and full upgrade. The customer wasn't down during all of this time, but during the data transfer, their services definitely took a hit in performance. Our identity management passwords need to be reset because we had good backup and restore, but it wasn't that good. It's gotten a lot better. This was years ago, so. And we missed a couple of scripts. So basically, we have RStudio and a bunch of other peripheral services and tooling around these clusters. And we missed a couple of scripts that had to be just transferred over in the customer. It was somebody mentioned scream tests earlier, and you kind of, one of those things where if you don't have something, you might not know until the customer yells at you, and that's really what it was. We didn't realize that these scripts weren't being backed up, and in this case, we did. So not good. It's not what you want. So we're going to use Salt to speed it up, right? And there's a few ways that we're going to do this. The big one is we're not going to redeploy an entire production system and transfer everything over. That's really not necessary. We're going to kind of look at what we have and see if there's a better way to upgrade all of it. So we're going to do some service rollovers via pillars. So we use external pillars in the form of Postgres pillars. So we have an external pillar module which reads JSON-B in Postgres and does a dictionary merge based on some queries. It's really something that we should put back into Salt. So maybe I'll do that, but haven't done it yet. All right. So we're going to have some new states to do some of our identity management syncing. So this way we don't lose anything, and we can do a nice failover of our identity management. And we're going to do application and database replication and rollover. And that should smooth things out a lot for us, right? So this required some new states, some new formulas, and we took heavy use of Salt API and Ruby in order to do this. So again, this is me coming from a Ruby on Rails web development background, and we have a bunch of Ruby on Rails people at our company, so it made a lot of sense to just keep everything in that kind of realm, especially because the frameworks are so good for this. So we're going to implement a couple of strategies, right? First of all, before I move on, are there any questions so far, everyone? Everyone good? Cool, maybe after this. All right, so we're going to implement a few upgrade strategies. There are many more upgrade strategies, but these are the ones that we're really going to use. So there's InPlace Upgrades, Replication with Restore, and blue-green upgrades. So InPlace Upgrades, basically InPlace Upgrades are what you think of when you look at your laptop, basically. If you want to do an upgrade on your laptop, it's going to shut down, it's going to install all the packages, download them all. It's probably going to install them, then shut down, then come up, and you're going to have to restart all of the services. So that's really what you have with an InPlace upgrade. And there's no way that you can get around that. You really have to like stop and shut down machines for kernel changes to take place. This is fine. This is OK. It's not good because you're going to notice that some services will come down, right? You're going to have downtime in any non-HA services. If you have an HA service, you can kind of shut one down, bring it back up upgraded, shut the other down, bring it back up upgraded. But if you don't have an HA service, you're just going to have downtime. So this is actually a pretty easy one to support. You can write all of your states to upgrade. You can pull down packages. It's great with Salt, really. It can be implemented extremely easily in Salt. But you're going to have some compatibility issues, we've noticed, because you're trying to install packages on a machine which has previous packages installed on it. And for us, you start running into some issues there. Even if you're going with like known good to known good, the reason is that, especially on a Hadoop cluster, if somebody needs an extra tool or an extra service, you might have an ad hoc package, right? So we try to keep a very tight ship and keep control of all of the packages that are installed on our machines. But if you need an extra tool, if you need MongoDB installed on one of the nodes, and it's incompatible with the next set of packages that are going to be installed, no bueno. All right, so we have replication with restore. This is like pretty similar to how we did our first upgrade. And we're going to continue using this, just not at the same level. Not for the entire process. We're going to do it as little as possible. And basically, you back up, you spin up a new one, you restore to it, or you back up and you restore to a new version. And this probably works on a strategy that you guys already have if you're a big data company, or if you're, I guess anybody's already going to have this. If you have a Postgres server or any kind of application state server, you're going to have a backup system that you can restore from there. And sometimes that's just RDS, right? Or another cloud-managed service that you have restore. With us, it's a little more complicated. And this isn't really feasible for a large database. You can do it downtime, right? It's not great. And again, application state. Then the last one is blue-green upgrades. So we use blue-green upgrades. The idea here is that you have one service, which is the old version, side by side. You spin up a new version. And this new version can be qualified and tested using some of the same, some of the same commands that are getting thrown to the old version of the software. You can just send those right through to the new version, test out that the outputs are the same or that the new one is working. And then you can roll over using DNS records or load balancers or IPs, however you want to do it. And you really get minimal downtime with that. That's the benefit there. So really the only thing that causes downtime is caching that you might have or the duration of your TTLs for DNS, who knows. And the bad thing about this is it's a little complex, right? And you can leverage some services to make it less complex, but it's not the same as just running your high state with an update flag or something like that, right? You really have to write states to do all of this provisioning. It's a little more complex. All right, so we have some Salt decisions that we made in order to implement this. And We do use Salt Orchestration. I actually really like Salt Orchestration, and they've made it a lot better since the first time that we used it. So we'll probably start implementing more of our stuff and have started implementing more of our stuff in Salt Orchestration. But there are some downsides to Salt Orchestration. There's no granularity on retry or undo. So we can't, you can say, you can now undo a state, and you can retry a state in Salt 2017-7. I think maybe before that. Logs are very hard to trace with Salt Orchestration. And we had a lot of early adoption errors. Again, these are fine now. We could start moving all of our stuff over because they're really filling out these features. So SaltCloud. We have to support multiple cloud providers, and SaltCloud is just an awesome way to do that. You get really clean declaration of all of your cloud configuration. It's nice, but for us, it had limited retry handling, and cloud provider errors are so like, they're very random. We get them all the time. Sometimes a machine will come up and it will just be slow, and we'll have to detect that, kill it, spin up a new one. Sometimes they won't come up for some other reason. Sometimes they get stuck in the provisioning state. There's just a slew of reasons that being able to control that logic ourselves was a better idea, especially at the time. And we also needed some beta feature support. So right now we're doing AD stuff. We've done managed disks in Azure. And that's stuff that you really have to break into the Azure CLI or the Azure API. And Salt just didn't quite support that level. Again, we could have extended Salt, but this was a decision made early on. So we just kind of stuck with it. And Ruby and Salt API. So I kind of touched on this before, but you kind of get all of the benefits. It's a language in of itself, right? You write all of the control flow. You can do any retries, and the unit tests are super easy, but like you have to write more code. So we already are using Salt. You don't want to write a new application just for your upgrades if you already have Salt. Unfortunately, we did. The one benefit of this is it's very easy to package up Ruby and run it. So it's kind of a good place to be in because you can just have an artifact that you're pulling down with the new version and then deploy it, and it will bootstrap the upgrade. So that'd be a little bit harder to do with file roots and Salt, but it could definitely be done. All right, so this is a complicated slide, so we're gonna take just a little bit of time on it. Everyone okay? Can you hear me still? Is that all right? Okay, so before we start on this, does anybody have any questions about what? With our first customer? Oh man. Yeah, we upgrade Salt ourselves. Yep. So I think we're using 2014, late 2014, early 2015 for it. But yeah, so that's one of the issues. If you're trying to do SaltCloud, right, you might need the newest version of Salt in order to do your deployments for SaltCloud. So you have to upgrade Salt and then do your deployment. And then so we didn't stick with that. We kind of, I think, found a slightly easier way to go about it. So we want blue-green for our upgrades, really. We want to spin up services side by side and then roll over to them in kind of a seamless fashion so that our customer doesn't know, right? Ideally, we could upgrade the customer while they're using it and they wouldn't ever know that we were doing it. In practicality, it's probably not going to happen, at least for a while, but hopefully we can get closer and closer to it. All right, so this really works when you have microservices, stateless apps, or sometimes services where you have to sync. So if you have an ID, we use free IPA for identity management at the moment. So this kind of works when you have an IPA server or an IDM server. You spin up one side by side. You do all of the syncing so that they're both working, and then you can roll over to it. So the first step of this is you bring up VMs. You launch new VMs to replace the old ones. Upgrade all of the, so during this process is actually really good because you can upgrade all of the hardware. You can throw it on we're in the cloud, so we can spin up a brand new VM type if there's a more performant or better cost VM type. So what we do is we spin up the VM, and have it bootstrap itself as a Salt minion. We wait for the Salt minion API or the client to connect. So you can either wait for the Salt minion. So interestingly enough, this is spinning up a new VM that is a Salt minion of the old master, and is itself a master running Salt API. So a bit confusing there. So the upgrade service is going to wait for the client to register or for the API to come up, possibly both. And then we're going to do a transfer of master signing keys. You can also transfer any other keys that you need if you're doing this. Yeah, basically you can transfer keys. So what we're doing is we're transferring the signing keys so that we can have our minions, which are validating the master signing keys, just keep the same keys for the moment. We can roll them over later, but it just helps roll our minions. All right, so the next thing we're going to do is we're going to configure Salt. So this is when we're actually more or less upgrading Salt and rolling what are our old Salt minions. These are going to be the Hadoop clusters or whatever nodes that have a lot of weight, really, a lot of data that can't be replicated and do a data transfer. So we're going to use, our external pillar in Postgres, and we're going to post to Postgres, add a new entry that updates our Salt master pillar record. And after that, we're going to redo all of our client config to point to the new Salt master. And then it will restart itself. So we just have a watch state, which says if this config changes, restart the minions. And then we wait for all of the minions to register with the new master via the Salt API. We just check which minions have registered. Once all of them have registered, we're spun up on the new master. Right? Then we can bring down our old master or continue with upgrade processes that we have. So that's there is downtime in this, so there are ways that we could get less downtime, but that's what we're doing right now. The downtime is however long it takes to start the Salt client, so it's pretty short. So really, after we're done with that, we've rolled over to the new Salt master. That gives us any new feature that the Salt master has, and we also deploy the Salt master with all of the states that we need for the next version of our product. So when we run a high state now, any machine that was using the old states and is connected to the new master can now reconfigure itself to use the new states, basically. So it's kind of upgrading itself. There's another step, but it's basically it. And we can also do any DNS failovers once services are started. It's not important right now. So we also still have upgrades in place. This is for our Hadoop clusters. The big thing about upgrade in place for us, we do our upgrades by like publishing an AMI. Are you guys familiar with AMIs and VHDs in Azure? So it's a machine image, like a virtual box image or a Vagrant file. So we promote through the entire dev cycle and QA cycle machine image, which we use for upgrade, right? So the new machines that are launched are going to use that machine image, but all of our old machines need to be updated basically to match this machine image. So that means any new services, any new packages, we keep a detailed list of every package installed, and we're going to install via the salt package.installed the list of all of these packages, and we just export those in as a pillar. It's a JSON file. Yeah. So we're going to do that. There's a couple ways that we could do this, but the way that we do it is our Salt master has a list of all of the packages that need to be installed, and it actually has all of the packages on it in a local Yum repo. And this means that we don't have to have our Artifactory up in order to upgrade the customer. If we want to upgrade them, we don't need our Yum repos that we manage to be up. We can promote, or we can push the local repos on the new Salt master that we've launched into a Yum repo either locally on each node or as a yum repo and object store, right? So after we're done with that, pushing these and configuring these new repos, we can have the Salt master call on these machines that haven't been upgraded yet, our upgrade state, which upgrades all of the packages on the machines. And during this, it actually upgrades the Salt minion service. So we kind of, we have this pillar data that has all of the repos or all of the packages that we're going to update, and we pull out of it Salt. We don't update Salt during that, because when you update Salt, I don't know if you guys have done this, it kills the minion. And you can do the Salt update execution module, but we don't use repos that are consistent with how that behaves, so we kind of had to do it our own way. So we pull the Salt, all of the Salt packages out and do that in another step, which is a backgrounded cmd.run. And then we wait for all of our minions to reconnect and validate that all of the packages have been installed correctly. So once we've done that, we have an upgraded system, basically. Yep, all of them. Yep, so that just ensures that we're using the exact packages. And we've actually had it where a package in there was missing because somebody had run an update on the system and it had gotten to a bad state. So we had to kind of manually go and figure out how to do that. So there's definitely some issues with that technique. Yeah. Yep. No, yeah, so we actually pull minion packages out of the rest of the package updates. So we update all of the packages, and then we go back and update all of the Salt minion packages after that. Yeah, so if they weren't two things, and you just did a package.installed on Salt minion, or package.update Salt minion, as soon as it updates and installs a new version, it will actually stop any Salt minion process that's running. No, you're right. It wouldn't impact our application processes. No, we're not using minions to start our applications. The issue isn't actually that. It's that when we're running an orchestration state to do this, the orchestration state will see a failure in our package installs if the minion connection drops, right? So we try not to drop that minion connection during our package install states. Yeah, we do two right now. Well, it's one orchestration state with multiple jobs, basically. Yeah. 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 No. We don't have any issue with the minion dying and it killing any other applications. We just want to make sure that the Salt minion isn't going down while we're trying to do other package installations. That's why we're separating it. But there's for most people, the Salt minion update util is going to probably work just fine. All right, so the V2 summary here. So there were fewer manual steps, right? So basically, there were two things that our support engineer had to run, and they went very smoothly for the most part. There are still a couple glitches every now and then. Again, I mentioned one where somebody had installed another package on there, so the packages didn't quite match up exactly. It still requires a moderate service window. This is, it's okay, but you don't want to schedule service windows that impact your customer's ability to run queries. A lot of people have batch queries that run overnight, and they use the database over the day. So you kind of have to put your support engineer into the position where he's Sunday or Friday night at 12 a.m. or some other odd time trying to do these upgrades. So minimizing it is definitely helpful. This is much easier to maintain. It's way easier to improve, right? So because we're using a lot of the orchestration steps now, we're in Salt, we have way more control and way more ability to improve this system, this project. It's relatively seamless for the customer. They have a brief service window, but other than that, they really don't notice anything. And it's still hard. I think any upgrade is going to be hard to detect and recover from errors, but this definitely makes it better. We have great logging. We're figuring out some of the complexity of Salt orchestration, and we're finding ways to capture the logs from that and debug any issues that we run into that. So we're getting better at it, definitely. And we have some improvements that we really want to do. So Salt has a minion master failover, so you can set a failover server on the minions. So we want to investigate that and start using some cloud load balancers rather than rolling over DNS records, which we do right now. The downside of DNS records is some Java services actually cache DNS, even on a negative lookup, which is no good. You have to restart your Java service or wait 10 minutes. It's frustrating. And there are configs that you can set to limit it from doing that. But yeah, it's bad. So a load balancer really helps with that. It just makes things smoother. So we also want to start pre-staging things. So I mentioned that we push things up during upgrade in place, and then we pull them down on the minions, the repos. But you can pre-stage those, right? You can just have your repos up in object store. You don't have to push them up. You can have another service that pushes up everything, gets everything ready. And you can do a lot of this stuff, including launching machines side by side entirely out of your service window with very little impact to the customer would never know. So then when you start your service window, all you have to do is a little bit of configuration, a little bit of rollover. And parallel steps are actually something we're really excited about. So we're doing a high state on some of these nodes that we're running, which basically means they're installing either new versions of Hadoop or redoing a lot of Hadoop configuration and getting some keys from our IDM server. And if you can start parallelizing that and keeping the requisites, it just vastly improves the speed of those. And of course, the retries and SSH is going to help for some of our edge nodes. All right, so that's all I have. I expect there to be some questions. So, any? Yeah. Yeah, so one of the benefits of being a database as a service is you kind of get to say, we're going to upgrade you. And in order to meet our compliance, we really have to upgrade these people, right? Like, you can't meet compliance and say, we're never going to upgrade your system. It just doesn't work that way, especially when you're in the cloud. Like, a lot of times that's a big sell, right? Like, they might not want to be upgraded at a regular basis, but once people have hesitancy to move to the cloud because of security anyway. So once you mention the security aspect, most people are pretty up on getting upgrades. But yeah, we do have some issues, or sometimes when just because of how things work out, a customer will be a couple months or a month behind. But that's it's a rare case, I would say. Yeah. Yeah, we really choose to. I think the thing is we want to view our. We don't view Salt as a management tool for our product. We really view it as just like inherently part of our product, right? So upgrading it, we have APIs that call out to Salt to perform actions within the cluster. So if you start upgrading part of your applications without upgrading Salt, those might not work anymore. So we really want to upgrade all of it at once and view our entire and our entire stack as the product, not just our application layer and then our Salt management layer. Any other questions? All right. Cool. That's all, guys. Thank you for listening.